This lecture is about slope and proportional relationships, specifically what is slope and how is it determined. Well, let's take a look at a word problem. I think this will kind of help us out a little bit, taking a look at something with words. We can say a whale eats an average of 2 tons of plankton every day. And we know that the relationship, that we can write a rule based on this relationship. And the rule that we would write would look something like this: y equals 2x. Now, we can, either by the equation or by the words, we can construct a table. And in this table, we can construct that. We know that we have 0 days, we'd have 0 plankton. In 1 day, we'd have 2 tons of plankton. In 2 days, we'd have 4 tons of plankton. The same could be true as being able to put those numbers into the equation. Because of this, the independent variable is the x, which we find right here. That obviously reflects our days. Our days are independent. It's a variable whose value determines the value of another variable, because it depends what number we put in here that's going to give us the y. And that's what makes the y the dependent variable, because its value depends on the value of another variable, and we call that variable the independent variable. So when we're looking at dependent, independent variables, know that x is always the one that we're changing, the one that's independent, and the one that depends upon what we're doing is going to be the y. Now, let's kind of take a look at a graph, how this all goes together. And if we were to graph these points 0, 0, 1, 2, and 2, 4, they would show up as such on this coordinate plane. But let's take a little closer look at what's going on in the table. And in the table, we can see the changes going on here. We see there's a change between 0 and 1 is 1, a change between 1 and 2. So we know that these changes exist. We can see also the change in y from 0 to 2, which is 2, and 2 to 4, which is also 2. Now, what this tells us is that the change is staying constant as it goes along, which would kind of make sense because the line is increasing at a constant rate. It's not zigzagging. So we want to take this idea, and how does this apply again to slope? Well, let's take a look at the graph. If I take this 2 over 1, we see the y is changing by 2, so we're going to climb by 2. And the x is going to change by 1. We could keep doing this 2, 1, 2, 1, and we would stay on the graph or the line itself. What that does show us is that slope is consistent. Now, most of us are very familiar with the fact of slope, the word slope itself, and slope formula. Here we have the letter m, which represents slope in an equation. Here we have the slope formula, which is the changes in the y's divided by the changes in the x, and that's what this means right here, the change in y divided by the change in x. So we're going to concentrate on looking at slope and how it's affecting angle and things like that, and how can we tell if something should have a positive slope, if that value should be negative, or if that value should be 0, or maybe even undefined. So let's kind of take a look at something here. Here I have 4 graphs. And I'm going to use my friend Red here to kind of help us to talk about each of these graphs. Now, we work on our graphs going from left to right, just like we would when we read. So we're going to use Red to do that for us as well. So as we see, if she goes along here, she's kind of going uphill. Well, because she's going uphill, we're going to say that values that are similar to this type of slope will be positive values. And when we're talking about positive values, we might be talking about like positive 2, positive 4, but more so like fractions and improper fractions like 5 over 4 and 2/3. These are the types of numbers we're looking for. So again, we take Red on a walk over here, and we see she's going downhill. Well, we know that numbers that go downhill would be representative of some kind of negative numbers. So types of negative numbers we might get is maybe negative 4/3, negative 1/5, negative 12. These are numbers that are negative that we could use for our slope. Now, we talked about uphill, downhill. What about straight across? Well, we know there are numbers that are positive, negative. Well, that would mean that here we would need numbers that were 0. And at first you might think, well, there's only one representation of 0, which is 0. But actually, there's more than that. When we have a 0 in the numerator of a fraction, we know that that fraction reduces down to 0. How do I know that for sure? Well, let's kind of go over something. Most of you should remember that 20 divided by 4 is 5. We can use the opposite, that 4 times 5 will give us 20. We can use that opposite idea to find out that value. Well, isn't it true that 5 times 0 will give us 0? If that's true, that means that this does reduce down to 0. Now, the problem with Red walking over here, she can't walk on this, which means that that's an impossible situation for us. So if we don't have positive numbers, we don't have negative numbers, we don't have 0, we have what we call undefined. And any number that exists can be represented also as a fraction as undefined. This time, we're going to have the 0 in the denominator. The reason we would do that is, again, we would ask ourselves, what would we multiply 0 by to get 6? Right now, absolutely nothing. It's undefinable in our world. And so anytime we come across a fraction that has a 0 in the denominator, we would then be able to say that that is undefined. Now, we'll take a look at this a little bit deeper when we talk about the next thing and the change. And when we talk about the change in y over the change in x, we're basically talking about the rise of the line versus the run of the line. Because we know that rise goes up and down, and that's the y-axis, and that the run goes across, and that reminds us about the x-axis. So we want to think about rise over run. So let's take a look at this graph here. And when we're looking at the graph, we have a couple points where it's exactly crossing on the graph paper here. And we're going to count rise over run from one point to the other. So let's do that. We're going to count rise. So 1, 2, 3, 4, 5. We can see that that rise is positive 5, so 5 boxes. And our run is a positive 2. So if we were to record the change in y over the change in x, we would get 5 divided by 2. This would be the slope of this line. Now the line can be made steeper, it can be made flatter. Let's take a look at some more lines. Let me put a couple up here for us. Here we go. We could have a line that's going a little bit flatter. We could have a line let's put a line that's going straight across. We'll add a line that's going up and down so we can talk about all these different kinds of lines and how they relate to rise over run. Again, let's do rise over run of this line, this first one I put up here. And here we can see that our rise would be positive 2 and our run would be positive 3. So this time for this particular line right here, our slope of this line would be 2 over 3. Now, you'll notice that 5 over 2, we know that 5 over 2 is greater than 2 over 3. Well, because the number is larger, we see that the line is getting steeper. Because it's getting steeper, that means that things are rising at a much quicker rate. Now, how do we apply that, though, to these lines? Let's take a look at this one up here first. There is no rise at all. It's not going up and down. And because you can't get from point to point, you're not going up and down. That means that we're going to have 0 in the numerator. Now, in order to go across, we could go across by 2, by 3, and we know that 0 divided by any number is going to equal 0. So again, here proves our point of y, it equals 0. Again, here we can have rise over run, and when we look at this particular one over here that's going up and down, we can see the rise. We can take from 2 points, let's say from these 2 points, we can see it's rising 3, but it's not running anywhere. It's staying on top of itself. And we know that when we have a 0 in the denominator, that works out to be undefined. So this kind of gives us a little way of looking at it through a graph perspective. Now, let's go back to this part, the m, and when I say that that's part of the rule, that's the part that we see in an equation. So let's go back to our original story about the whale and the plankton, and we can kind of see where all of this is coming into play. Again, we saw the changes before, and we said the change was 2 over 1. And here it is. Here's that 2 right there with the x. So we know that the slope can be found when we're talking in this order, when we have the y by itself, or what we call function form. When we have the y by itself and the x is on the other side, we know the number that is with the x represents the slope. This also is represented by y equals mx. Y, slope, times the independent variable times the slope is going to equal the dependent variable. So again, we're going to kind of keep those terms in mind. A couple last things for us to look at is let's take a look at it from the point of view from a slope formula. When we're working with slope formula, we're going to use that with 2 points. So this is about what I mean. We're going to keep these, take the y's, put them in the numerator, put the x's, put them in the denominator, and we're going to subtract them, because when we subtract them, we can find the distance between these points. So let's take a look here at this example, and the 2 points are 3, -4, and -1, 2. We're going to just take the y's and we're going to put them in place of the y itself there, and then we'll take the x's and we'll put the x's down below. One of the things you might want to do to keep things straight is to circle your y's when you're doing these problems, because then it's very visible that you're keeping the y's on top. Now, as far as the x's are concerned, we want to make sure that they make it to the bottom. You'll notice that this was a -1. I did not cover up that minus sign because remember, I'm taking the difference between these two, taking the distance. So we want to make sure that we're not saying, oh, it's negative, it's already there, because it's not. Okay, we're going to simplify this. -4 minus 2 is -6. 3 minus a -1, we know that a negative times a negative is a positive, becomes +4. We need to simplify this further, and then this becomes -3/2. We'll do this a couple more times so that you kind of see how to get the hang of it. We're going to circle, here we have the points 2, 5, and 0, 1. We're going to circle the points 5 and 1. And we're going to make ourselves our fraction. The ones I circled, which is the y, which is the rise, we will put on the numerator, and in the denominator we will put the x's. Then we go ahead and just use our integers. 5 minus 1 is 4, and 2 minus 0 is 2. Again, we have to reduce all the way down. 4 divided by 2 is 2. We'll do this one more time. Here again, we'll take the points 3, 2, and 3, 4. And we're going to take these points here that we put as in the numerator, the y's, we'll put 2 and 4 up there, and 3 and 3 on the bottom in the denominator. We simplify. 2 minus 4 is -2, and 3 minus 3 is 0. Again, we need to simplify this. We have to keep in mind, which one is this? Is this 0 or is this undefined? Well, if we don't know, we can do the multiplying. 0 times what gives us -2? Well, absolutely nothing. So we know that the slope then is undefined. Now, a way to think about this, think about how this would look on a graph. If I was to graph it, 2, 3, 4, we would have a couple points here. They'd be one right on top of the other. And because they'd be one right on top of the other, when I went to draw a line, and unfortunately I didn't draw a straight line, so I apologize for that, it would go right on top of it, be a straight line, and we know that we cannot walk on that, or our little friend Red, who helped us, couldn't do that either. So that we had no slope. That's the end of this first part of slope and proportional reasoning.